So the last piece of this 9-3 lesson on reflection is to talk about reflectional symmetry. So previously in this lesson, we've been taking a pre-image, drawing a line or finding some line of symmetry and then reflecting that and coming up with an image. What we're going to do here is we're going to just take this image and we're going to see if we can place a line in this image to create um, two equal pieces on each side. It might be easier to see here. Um, so here's a couple of pictures. We have a triangle right here. If we imagine drawing a line, or you could also imagine folding. Um, the next slide that I'm going to show you mentions folding. If you can draw a line and create identical left and right side pieces, then that line is called a line of symmetry. And we could, or it could also be considered a line of reflection. The ways that you imagine or that you consider placing the lines of symmetry um, is usually going to be a vertex from a vertex to a midpoint. And this is going to happen when you have an odd number of sides. For example, a triangle, or if you have what's next, a pentagon. You have a pentagon that has an odd number of sides. You might find the line of symmetry from a vertex to the midpoint. It's the odd number of sides that make us go from the vertex to the midpoint. If you have an even number of sides, you could find a line of symmetry by going midpoint to midpoint. Okay. And this one has two. So imagine it right here, you imagine it right here. So those are things to consider. Now, if it's a random shape or picture like this, you don't necessarily consider vertices and sides and everything. You're just going to have to imagine, can I draw a line of symmetry and cut this into two equal pieces? Okay, there would be my line of symmetry. Can I have a line of symmetry and cut this into two equal pieces? Okay, so that's two things to consider. There's also another thing to consider, and this is where the page where it says, hey, let's see if we can fold it. So if we have these special shapes, extra special shapes, where it's considered what we call regular, where it has sides that are equal and angles that are equal, you can go from midpoint to midpoint. You can also go from vertex to vertex. And on some shapes, you can even do both. So on this one right here, we've got vertex to vertex, midpoint to midpoint. So on this, because this is all of these sides are the same length, you can see we've got several lines of symmetry. So let's go back here and I'm gonna show you go ahead and pause the video and see if you can't draw the lines of symmetry, and then I will show you what I have. Okay. All right. I'm assuming you've put yours um, on here. Here's what Springboard said. So here is an example of going vertex to midpoint. Here's an example of going midpoint to midpoint in two different directions. And here's an example of going vertex to vertex again. And I bet if you count these, you'll see that you have an odd number of sides. So vertex to vertex, vertex to vertex. It's almost always one of those three. The only reason it wouldn't be is because it's a weird picture or something. Okay. So if it has, it says this one, what can you conclude about the triangle? Well, we're going to conclude that the triangle is equilateral. How are we going to conclude that it's equilateral? Well, if we take just one, any one, it doesn't matter. Let's take this one right here. Remember, this created, if it's a line of reflection, then these two pieces right here are exactly equal. So I've proven that this side right here is the same length as that side. So I'm showing right here that AB is the same size as BC. All right, so if you take that triangle, and I'm redrawing it because it's hard to see when there's all of that drawing in there. Let's draw a different line of symmetry. Let's draw this one. Let's draw L3. Well, L3 created two equal pieces. So L3 created this piece right here equal to this piece right here. Well, I've already shaded this one in red, so it's red indicates that they're the same length. So this one's shaded in red, and then this piece, according to this line of symmetry, is the same length as this one. So now these two are the same length. These two are the same length. And if I look at the other one, draw the triangle. And let's see, I've done L3, I've done L2, so let's do L1. When you draw L1 right here, it creates two equal triangles. And if these two triangles are equal, then this side is equal to this side. So now I'm showing that BC is equal to AC. So all three sides are the same length, and that makes it an equilateral. Okay, that's it for the new information. You have number 17 to do, 17, 18, 19, and then you've got the 9-3 practice. So I'm going to show you another one that you can do. Yes, this one right here. Um, and then I'm going to stop the video, and on my next video, I will share with you the answers. Okay. So you go to the check your understanding. You should be doing check your understanding, and then the 9-3 practice, and then see what you can do with this. And it just says, does it have reflectional symmetry? If it does, draw the line of symmetry. If it doesn't, put an X or say no or something like that. And on the next video, we'll check.